Alright, here we go. Graphing linear equations and inequalities. Again, pause now, read. Alright, now that you read that, pause this and read this. Write them down if you do not print out the papers. And some important terms to know. You're going to need to know your slope, y-intercept, positive slope, and negative slope. So, let's get this thing started. First, refreshing our memory by looking at a slope-intercept form of a line. We have y equals mx plus b, where m is our slope and b is our y-intercept. Our slope, if you don't recall, is m in our equation, but it's also found by taking 2 points. So I would have, say, x1 comma y1, and then I have another point, x2 comma y2, where the subscripts just denote first point and second point. And so I'd subtract them, and I get this, which also means rise over run. Rise can be our up and down, and our run is our left and right. Well, our right and our left. And B is our y-intercept. And what does it mean to intercept something? It's to cross, right? So B is where we cross our y-axis. Let's get this show on the road. If M is positive, then it will have a positive slope. A slope is a positive slope if the y value increases as the x value increases. And graphically, this is what I mean. If I have my x and y, I know it's kind of crooked, but my line will increase. So as I go in a positive direction on my x-axis, my graph is also going a positive direction in the y-axis. Now, m is negative, then it will have a negative slope. A slope is a negative slope if the y value decreases as the x value increases. I forgot to add that part down here. How that graph looks is, like this. As x is increasing, y is decreasing. The values for y are decreasing. So, positive slope, negative slope. So let's go ahead and figure out how to graph these. So like I said, this is our b. Our form is y equals mx plus b. Well, our b here is -1, which is our y-intercept. So a good starting point, our y-intercept is always a good starting point. So we're right here. Now our slope is 2. Now 2 can also be looked at as 2 over 1. So which equates to our rise over run. So from our starting point here, we're going to rise 2 and over 1. Rise 2 over 1, rise 2 over 1. And we can go ahead and get our graph. Oops. This is going to be, there we go. And then back down this way. We could see that we have a plus here, so we have a upward sloping or a positive sloping graph. Again, our y-intercept at this time is a positive 3, so this time I'm going to start up here at 3. And my m equals -1/2, so I'm going to go down 1 over 2. Our rise is -1, our run is 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. Say if, for example, we couldn't see this whole part of our graph, right? And I had to start here because this is my starting point. We could also look at this as a 1 over -2, right? So I can go a -2 in this direction, up 1. -2 in this direction, up 1. So that way I can get this side of my graph as well, and then I connect my dots. And that line should be straight, obviously. Let's do another. Now where's my y-intercept? It is at -4, so I'm going to start on my y-axis at -4. 1, 2, 3, -4. And now I have a slope m equals 3 over 2. So we have our rise over run again. My rise is 3 this time. 1, 2, 3. And my run is 2. Run is 2. Up is 1. And we can continue that same pattern. Over 2. Up 3. And just continue that straight on. And then we can go down 3 to the left 2. And just connect your dots. Now, another problem. Our y-intercept is at -6. So 1, 2, 3, 4, 5, -6. Now, Rm is -3 over 2. Now, I cannot obviously go down 3 and over to the right 2 here. I come off my graph. I can't. My pin doesn't even go down that far. So my other option is, like I said, look at it as 3 over -2, where we still have our rise over run. So my rise is now 3, 1, 2, 3, but my run is in the -2 direction. Rise 3, -2 direction. Rise 3, -2. And then we could now see our line. And again, that should be straight. This tablet I'm using is a little tricky. All right, let's go on to one more. Now this one, how do we graph this? Whoa, what's happening here? Well, we have to get it into our slope-intercept form. So, in order to do that, we still need it in the form y equals mx plus b. So we need to isolate y by itself. So first, let me go ahead and distribute my negative here. Boom, boom. So I have y plus 4x equals -x plus 4. So you have to distribute it to both terms. And now I'm going to go ahead and subtract my 4x out so I have y by itself. So I get y equals -x minus 4x is -5x plus 4. And now it's in our form y equals mx plus b. So my b is positive 4. 1, 2, 3, 4. And then I go -5. So it is -5. Consider it as -5 over 1, right? All of our whole numbers are always over 1. We just don't really write that. So I go down 5. 1, 2, 3, 4, 5 over 1. So we have a really steep graph here. 1, 2, 3, 4, 5 over 1. And then we can go ahead and kind of draw our line here. Again, sorry for the not completely straight line. I expect yours to be straight if you have a straight edge. Now, graphing linear inequalities. Pretty much the same exact thing. All right? Just one extra step. So let's take a look at our inequalities here. All right, so graphing linear inequalities. Not much different here. So we could look at this as, to get the line, as y is equal to x, right? When we know that if x is 1, y is 1. If x is 2, y is 2. And so we looked specifically at just what is happening on each side of the inequality to graph it. So look at it as y equals x. So we know that this graph looks like that. Now, can it be equal to? Well, the first thing we have to know is that we have two different types. We have y is greater than or equal to x, and then we have, or sorry, y is greater than x, and then we have y is greater than or equal to x. Now, if y is greater than x strictly, can it equal x? No. So my line has to be a dotted line. Just like on a number line, if you have a number line, you have an open circle if it's greater than or less than. Well, on your graph, you have a dotted line. Now, here's my y equals x line. Now, it's saying what y has to be greater than x. So what I always do is after I find my line, I take 1 point above it. So I know that this point is 0, 0. I'm going to come up here to this point 0, 3. Now, 0, 0, and this is 0, 3 point. Now, where is y greater? And I'm going to go ahead and do one down here. So that's 1, 2, 3, 4, -5. So 0, -5. Now, my line is at 0, 0. I need to find where my y is greater than x. Well, is y here, is 3 greater than 0, or is -5 greater than 0? 3 is greater than 0, right? So then this will be the side that I shade. Here I have the same thing, except this time y is less than x. So my line is not changing. It'll be the same. However, if I pick my points, is this y greater than this one? Yes. So is that going to work? No. We want a y that is less than it. So here I have negative 4, which is less than 0. So I'll shade on this side. Now here, this is the same as this. However, I have this line under here, which means it can be equal to. So when I draw my line this time, I have a solid line. Now y is still greater than x, so I still need to choose a y above my line. And this one's greater than it, so I'm going to shade on this side. Y is less than or equal to x, so again, I have a solid line. This time I want a y that is less than or equal to x, so less than will be below my line. So let's look at some more real examples. As we look at this one, we have y is greater than 2x plus 1. Now we know that this is still in our mx plus b form, where our slope is 2 and our intercept is plus 1. So we'll start here. With a slope of 2, we go up 2 and over 1, up 2, over 1. And we can go down 2 and over 1 as well. So now we can go ahead. And because I have a strictly greater than, can it equal to it? No. So now our line is going to be a dotted line, signifying that our solution is close to that, but not exactly equal to it. And I need a y that is greater than it. So if y is greater than our line, I have a 0, 1 here, and this is a 0, 4. 4 is greater than 1, so I'm going to go ahead and shade above it. Moving on to another inequality. Y is less than or equal to, so what kind of line we're going to have? Correct, a solid line. Less than or equal to negative x plus 4. Again, this is still in the form mx plus b, so our y-intercept will be at positive 4, and we have a negative 1 slope. So negative 1 is the same thing as negative 1 over 1, down 1 over 1, down 1 over 1. And then we can see that we can just go ahead and draw our line right through there. And this time y is strictly less than it. So I need a number that is less than 4 on my y-axis. 2 is, and I can see that it is below it. So then I will shade everything below my line. And one more example, I believe, and we should be on our way out of here. So y is greater than or equal to negative 1/3 x plus 3. Still in the form mx plus b. Our b is plus 3, so we'll mark that. And our slope is negative 1/3. So we go down 1 over 1, 2, 3. Down 1 over 1, 2, 3. And we could go the opposite direction as well. And it's greater than or equal to, so we have a solid line because it can equal it. And because y is greater than, we will shade above. Oh, I had one more. Sorry, lied. Y is less than or equal to 4. Now, where's our x? Where's our mx plus b, right? So let's think about this. Where is y equal to 4? Well, y is equal to 4 right here. Where else is y equal to 4? Well, here, and here, and here, and here, and here. Y is equal to 4 anywhere along this line. Right? If I choose any point along this line, aren't I equal with y equals 4? Yes. Now y has to be less than or equal to 4. Well, which values along my y-axis are less than 4? Well, the ones below it. So I shade everything below. All right, and so there you go, graphing linear inequalities. Make sure you answer the questions pertaining to this video, and I will see you Monday, Tuesday. Don't forget, random note check might be happening. Have a good weekend.